thought I had hit the button, but it was waiting on another button to be hit. Hey, look, we've begun. Watch this. Watch this, I say. Yes, all right, that's enough of that. Hello and welcome to the show. It's me, John Park. This is John Park's Workshop, and now I think we're actually broadcasting over on YouTube. So thanks for stopping by, and thanks for your patience with me as I click buttons. Let's see, oh man, the Facebook isn't running. But the, looks like Restream is. Yes. Restream, are you going? You tell me, viewers, where do you see it? Is it here? Is it happening? Oh, wait. I don't know why. The Facebook has been super inconsistent lately. It looks like it's going. Yeah, okay, I see it there. It has a preview and everything. I'll leave that alone. All right. That's probably good enough. Fine on YouTube, says Dave Odessa. Hello, yes, so hello to the YouTube chat. Beatograph Abdelhagen, Dave Odessa, Connor McCarter, thanks for stopping by. We've got our Discord chat right over here, adafruit.it/Discord, and you can look for the live broadcast chat channel. It's that one right there. Hello to Andy Calloway and Starman and Paul Cutler and Dave WA90NY. Andy Calloway there too, C. Grover. Hello. Thanks for popping by. So, jam-packed show for you today. I've got a coupon code for you. I have a product pick of the week recap. I have a CircuitPython Parsec. There's going to be a little preview of progress report on the computer space project, as well as more info on Guitar Hero, Clone Hero, Sand Troller, Feather, USB host RP2040 stuff, and LED lighting for that. The episode title, in fact, today says Light Up Guitar Strap. So I'm gonna show you some Light Up NeoPixel inside of Sand Troller stuff. I also have a little cool bonus related to, I teased this yesterday on the show and tell. I have a little bonus related to the computer space project that I want to show you and talk about. So first off, as promised, I've got a coupon code for you, which means you can head over to Adafruit.com, get yourself some stuff, throw it in the cart on the way out. Do not forget to type in this coupon code right here. It is shredded. Shredded. That kind of shredded, not this kind of shredded. Or I guess it could be both. But all you have to do is type that in. It's good until midnight tonight East Coast time. And that will work on products that we can put in a box or an envelope and send you. It's not good for software, gift certificates, or subscriptions, but it's great for stuff, physical things, bits that we can, atoms that we can put in a package and get to you somehow. So go check that out. And that will get you 10% off. Also, we have free stuff. I was just remembering that's what the pause was about. Let me go to Adafruit and I'll show you how to check that out. If you go to Adafruit.com, I think we have it down here at the bottom somewhere, freebies, or you can do Adafruit.com/free. But if you click on freebies, you will see that we have some neat stuff at 3 different spending levels. So if you spend $99 or more, you get a free PCB coaster with the gold Adafruit logo. If you spend $149 or more, you will get a free KB2040 keyboard. And if you spend $199 or more, you'll get free UPS ground shipping in the continental United States. Those stack. So if you get the free shipping, that means you also got the free KB2040 and the free coaster. So don't forget those levels when you go in, and definitely don't forget that coupon code, because that's a nice way to save a little bit of money. I'm going to have a drink of water. Excuse me. Okay, next up, let's take a look at the recap from this week's product pick of the week. So on Tuesdays, in case you didn't know, on Tuesdays, I have a show called JP's Product Pick of the Week. I pick a thing. I give you a big discount on it. We do, I should say. It's the new products team. Big thanks to them. Lots of help over there at Adafruit to usually stash 100 of the items, so we have some in stock for sure when the show launches, and put a big discount on it. If it's an Adafruit thing, we usually give you 50% off. This week we had these adorable little NeoPixel jewels. So here's a little 1-minute recap from this week's episode. NeoPixel Jewel. It is a 7 LED board that is perfect for wearables and props and other small applications of a whole bunch of RGB LED light. So you can see a bunch of individual LEDs. If you put a diffuser, in this case about an inch away from it, you can make it look like one big light source, which is pretty neat for some different effects. The further you get away, the bigger. But since that is multiple LEDs there, you can do some different color effects like comets and chases with them separated out. Nice little sort of flower petal Sparkle Motion Mini that I'm driving these with. That central, in this case, cool white, it looks great. It's not a combination of red, green, and blue that always gives you this sort of not really white. Those are white LEDs, and then the phosphors help guide that in one direction or another. The NeoPixel Jewel. We could use those for today's project. I'm not going to, but yeah, we could definitely use those for our light-up guitar strap or other festooned on other bits of gear, hats, suspenders, whatever you want, belt buckles. Okay, hey, next up, I've got a CircuitPython Parsec. CircuitPython Parsec. All right, for the CircuitPython Parsec today, I wanted to talk about how to use the built-in BME 280 temperature, humidity, and pressure sensor on the Feather ESP32S2 BME 280 variant. So we have 3 versions of this board. In fact, let me bring up the shop here first. So if you look at this right here, ESP32S2, we have a version with the BME 280 built right on it there. That's the one we're going to look at. There's also one that just has the PCB antenna, one with just the antenna connector. But this one right here does everything a Feather ESP32S2 does with 4 megs of flash, 2 megs of PSRAM, but it has a built-on sensor. And I want to show you how to use that because it is great for IoT projects where you want to get temperature and humidity in particular. Maybe you also want to get the pressure and altitude. The way to do this, if you take a look at my code window here, I'm going to go ahead and tell this code to run. And see right now I have every couple seconds it will pop up the temperature, humidity, pressure, altitude. I'm also telling it to show me the battery voltage and the battery percentage. So this is great to throw inside of maybe a storage area, or if you have a basement, you want to check the humidity levels and the temperature, or for 3D printing projects if you don't want to add a bunch of sensors to an existing board, but you just want one board that you can use for telling you the humidity of your filament, if you have a little filament dryer or that sort of thing, and the temperature. This is great for that, as well as different kinds of coffee projects. So in setting this up, we're going to import the BME 280 library. And you can see I'm also importing the battery monitor here, the Max 1704. And then I'm creating this BME 280 object as the BME 280 I2C over the board's I2C port. So it's just built right onto that bus, right onto the I2C bus of the board itself. It's not coming through Stemma QT. It's not plugged into some separate pins. Then we can go ahead and just print out these values, such as temperature, humidity, pressure, altitude right here by saying BME.temperature. That's going to give you the temperature in Celsius. BME.relative humidity will give you a percentage. Right here, it's a little humid-ish, 34%, not terrible. So the interesting thing, though, is this is a board that's really good at getting onto Wi-Fi. So if we take a look at this code right here, it's my Adafruit IO version of the code, and I'm going to go ahead and overwrite what's running on the board right now. hit save, and it should go ahead and connect up. If you look in the REPL, it's connected to ShopNet, which is the name of my router in here, Wi-Fi, connected to Adafruit I/O. And now it's just every 5 seconds, or I think it's every 10 seconds, it's going to spit out the temperature and the humidity, and it's going to send those up to Adafruit I/O. So if you take a look at my feed right here, I've got, let me see if I can make this screen fit a little better. Okay, you can see I have a feed and a graph and a couple of little blocks here that give me that information. So in the code, all it's doing is the same sort of stuff. It's checking that onboard sensor, but then in the main loop, when it is connected to Adafruit I/O, every 10 seconds, io.publish, I have the name of the feed it publishes to, in this case F for feather, FBME temp, and then it's again just grabbing that BME 280.temperature, and the same sort of thing for humidity, FBME humidity, BME.humidity. And that sends that up to that feed so that I'm able to keep track of that and watch that over Adafruit I/O. Using MQTT, so you could use it with other services as well. And that is how you use the onboard BME 280 sensor on the Feather ESP32S2. And that is your CircuitPython Parsec. CircuitPython Parsec. Where'd I go? Hey, hello. Okay, let's keep that moving along, just because I have a whole bunch of stuff I want to try to pack in today. Let me move on to, let's jump into some of this computer space stuff. So I've mentioned this on the show before because we talked about the model I'm building, the 3D model I built of the cabinet for Nutting Associates Computer Space by Nolan Bushnell and others. And it was a big fiberglass arcade cabinet with sparkle paint on it for most versions of it. So I've built this subdivision surface model inside of Rhino so that I can 3D print it, and so that it is sort of nice friendly geometry that I can go ahead and edit easily. There's an existing scan, a really nice scan. You'll find it on printables, and if you Google around, you'll see there's a nice high-resolution scan that was made of a real cabinet. I based this on that, but just redrew the geometry with sparser lines to make a subdivision surface. So this model here, I want to be able to put a little OLED screen in there playing essentially an attract loop of the game. And the original used a 13-inch black and white consumer television, so it's a 4:3 ratio, black and white. Lamore, seeing the size of the cabinet that I'd printed out there, said I should take a look at that OLED right there. Now you'll see it's a wider ratio, but I'm just going to mask it and only send graphics to a small area of that screen, which I'll bring up right here so you can have a look at it. So this is a OLED screen that we sell. It's 128 by 64 pixels, and I did some quick math and have changed the ratio so that it's 85 pixels wide, 64 pixels high to be roughly a 4:3 ratio. So that's what I'm working within. This can be a I2C display, which would be the slowest, SPI, which is sort of the most convenient and plenty fast, or an 8-bit display. I don't think I'm going to need to do that. I'm running this originally. I did a prototype in CircuitPython, but now I'm using Arduino and using Claude AI to generate the code for it, as well as some examples of some assembly language that someone wrote a PDP-1 version of. And so the interesting thing about the game is that it started out being inspired by Space War, which was on PDP-1, but Bushnell and others designed it to use TTL logic since it would have been incredibly expensive to do it as an actual microprocessor of any kind at that time. So any recreations now are either inspired by the way the PDP-1 version was coded, but with some of the changes that were made, or there does exist at least one FPGA implementation based on the circuits. What I've got here, I'm going to go ahead and enable the chip, is a little demo that has the two enemy saucers, UFOs, that move in tandem together in a zigzag pattern. Has my little rocket ship there that rotates around so that you can see how this inspired, this in-space war inspired asteroids. We have the looping, wrapping pixels of the bullets and the ships as they move around. We have a little scoring on the side as well as a count-up timer that goes from 0 to 99 seconds. I'm actually unclear in the game what the sort of win condition is, if it just stops at 99 unless you're winning, or if you've gotten to 9 or higher. I'm not quite sure, actually. I need to look into that a little. You'll see I have an error right now that I'm working on fixing, which is the redraw. I'm seeing a trace of the bullets from the player ship. The player ship does have curved sort of guided missiles, so when you fire, if you turn the ship, you can actually curve it around and try to loop it around to hit the enemy there. But this is, I don't have it playable, but this is all just an attract loop looking like it's playing the game and based on the way the game works. Yeah, I showed this, I think, did I show this last night? I'm already losing my mind. Yeah, I showed this last night, I think, right, Liz? Hello, Liz over in the chat, in CircuitPython, and this is now in Arduino, which is much, much, much faster. And in fact, one thing I really like is watch here when it goes to 99 to 0, the real game did this. I think maybe even they called this hyperspace, I'm not sure, but it inverts the display. And this looks particularly nice, like a TV to me. I'm not sure why it's dimmer. It may just be that the current draw is too much for the board, which is actually running off of 3 volts instead of 5 volts, which is how it was designed. But it may just be a current draw thing. Anyway, I like this. It looks like a somewhat dim CRT. And the redraw that you're seeing is a little bit exaggerated on camera. You do see it in real life, some of these vertical stripes that are moving through, or horizontal stripes that are moving vertically. But yeah, so every 99 seconds the game flips back to an inverted version of the color palette, which is interesting. So that's what I have, and I may leave it at this. I don't want to spend a lot more time on this loop. I think I'm just going to try to fix the bullet path, which should not be a trail. Otherwise, it's working fairly well. So that you can see here, even the pixels that are the star field end here and here and here. So that's the ratio that I'm going to show visible inside of the screen. And let me go ahead and turn this off. This is, by the way, right now running on a Feather M4. I may try a ESP32 S3 to see if that's even snappier, even faster. But if I take the screen out here, a couple things to mention. One, these resistors right here, I'm gonna refocus for you. So these resistors right here are actually how you set the mode from I2C to SPI to 8-bit parallel mode. So for some reason, mine came, and I think these can vary. Let me know if you've ordered one of these before and dealt with this. Mine came with the 2 resistors up on the R4 and R2 slots, which I don't believe is any of the combinations that work. So either it's both at the bottom for SPI, or one at the top, one at the bottom for I2C, and vice versa for 8-bit parallel, I believe. So I had to desolder and resolder these little SMD components, which is just a word of warning with this display in particular. It's not for the faint of heart. There's a little bit of SMD desoldering and soldering you're going to have to do. Potentially. You may get lucky and yours is already configured this way, but that's what I found with mine on this one. So I want to show you this in the cabinet. It actually, I did not design it with this in mind. I just designed it and printed it, and I think it actually works out perfectly because the TV was set back to this lip here, and then there was a glass front in the front, so I might cut a little piece of acrylic. And then there's masking because the TV was only 13 inches in a cabinet that stood this high. So I think I'll be able to mask it, set it there. I may tilt it up a little bit because this is going to sit on a desk, and I want it to look nice and show the display. But actually, I think that's Lamore for you. She looked at me holding this. She said, I think that 2.4-inch OLED will work, and she nailed it. So that'll be in there, and I may run a IDC cable, ribbon cable, out the back here, just a few. It's only 5, I think 5 wires plus ground and power to it. So it's not all 20 of those there. So stay tuned, and I'll show you progress on that and put together a little guide. This is pretty niche, of course, but if you like it enough to build one, maybe build 2 and give one as a gift, because once you're in there doing it, it'll be pretty straightforward, I think, to make duplicates of it. And there is not, as far as I know, a commercially available or even kit form of this sort of thing. There are some other small arcades out there, and in fact we've done some in the past. If you take a look at Learn and just look for arcade, you'll see this little Cupcade Raspberry Pi micro arcade cabinet that Phil Burgess put together, and I think there's even a smaller one they had done at one point if you look through here. One note from the Discord that I love, Andy Calloway says, don't forget to give the mask rounded edges, right? So we want to make it look like this ERT tube, so we're going to round it a bit. It would be neat to get a lens to put in front of it, kind of like we have lenses for our monster mask eyes, but I don't think I'm going to find a sort of rounded rectangle lens that would really make it look proper, but that is always the giveaway with things that are meant to look like a CRT and aren't, is being way too flat, unfortunately. Okay, so that's a progress on that, and I will, I think, share a little bit of the process of the prompts that I used in Claude in the guide for that, so you can see how I went about it, as well as some of the resources out there. I was able to, at one point Claude at the PDP-1 code that someone wrote based on Space War and computer space, and say, okay, this should give you a better idea about some of the physics of the inertia and thrusting and stuff, and I think it did a nice job of looking at that code and understanding better what I was asking for. So there you go. That's the update on computer space. Oh, look, it's flipped back around to our inverted mode. Let me focus that. There we go. Okay, next up, let me put this away. And I'd like to, some nice says you can get credit card size Fresnel lenses used for magnifying. Right, yeah, there's those little, put it in your wallet magnifier. That's a good idea. I should see how that looks. Thanks. Good idea, some nice. So the tease, the thing that I said that I wanted to show you is I actually have over here on my workbench a PCB set from Computer Space. So let me get this laptop out of the way here for a second. I thought I was going to do this in the other order, but I think this is a good time to look at this, and then we'll move into all guitar stuff. Grab some cabling here. So this is the PCB set from Computer Space. It was, looks like, repaired in 1970. Do we have a date? I thought we had a date on there of one of the repairs. I thought it was on there. Date 77, I think 2/10/77. So there it is. This is Computer Space. It actually had 3 PCBs in this little cage. You can see the edge connectors. All the boards are just slotted in with edge connector there, and some little guided plastic rails. I'm not going to pull it apart just because it's I don't want to break it. It's a bit fragile. And then these are all of the I/O connections to the cabinet. So to plug into sound, power supply, controls on the cabinet, coin stuff. And then here on this side we have a couple of operator options. So you could do extended play, yes, no. Would it be 2/4 or 1/4 for a play? And you could put a test pattern on there if you wanted to do some adjustments of your CRT, the television that it was connected to. And then there is a time adjustment here, which I don't know. I'm assuming that could sort of adjust the crystal to change the speed of the game, adjust the frequency on there. I have no idea what this piece of tape that says ear on it is all about. And then on this side of the cage was written the boards, which I don't know if they got this wrong and then used these arrows to say, oops, I got this wrong. I think so, yeah. So the top board is essentially the graphics board. The middle board is the motion board, and the bottom layer is the stars, the sync, and the sound. And the only reason that I have a lot of confidence about this top one being the graphics is if you look at the very top here, Nolan Bushnell designed the diodes that are used to configure the shape of the rockets. He decided to design the PCB to actually look like the rocket in rotation. And I believe this might be the UFO over here. But if you can see this arrangement of these diodes that are up mounted vertically, this arrangement of these diodes is the rocket ship when it's pointing up, and then rotated 3 different amounts, so that the shape of the graphic is different, and then I believe any other transforms are done with logic and mirroring of them. So I believe that's how this works, and my understanding of it is really limited, but that's a combination of that's things I've read, is that this is in this section, this design of the rockets is based on this use of diodes, and then just for, I think, purely artistic purposes, and also as I read online, it makes it really nice for testing because these diodes do correspond to the pixels that make up the ship, which is 1, 2, 3, 4, 5, 6, 7, plus the thruster at the bottom. But 7 pixels high, and I think maybe 6 wide, or 7 wide, 1, 2, 3, 4, 5 wide maybe. So that is really cool, really something else. Connections in here, I'm not sure what these, let me zoom out and focus. I'm not sure what these 2 wires are. There's actually 3. There's a set of 3 wires here that come off of somewhere on these harnesses, but aren't hooked directly into these standardized connectors that are on the side here. I'm going to just pop up my chat. Oh no, I just lost a key piece of evidence there, and I don't know which board. I think that was on one of the boards in there. I think it just fell out when I tipped this. But this, you can see, was ACS Distributors Sales in Quincy, Massachusetts. Logic Repair by 1610, date 3178, repair number 2042. So same, I believe that's the same same place repaired this as well. So yeah, it's one of those two boards under there. I believe I took pictures of these one time when I pulled them apart. So oh, you might not have been able to see. Sorry, I had my camera. I might not be able to see that. I had pulled out all three and took photos of them, so I know which one that goes on. So that's a little bit of history there. I have not hooked this up to a little DIY harness like I have with some other arcade boards, because I don't want to blow this one up, so I don't trust myself with this one. So this one I think I'm going to leave to an expert. If you happen to know of any experts or people in that collecting of that kind of world, put them in touch with me, or send them some Adafruit info and we can talk. All right, so that's what's going on with that. Gary T asks, does it have the great PCB smell? It definitely has an old electronics smell that is kind of the smell I associate with surplus electronics, which probably means it's horrible carcinogens. I don't know for sure. Okay, so let's move on. Let me just put that away. A little box for that. And we're going to dive into some of this Guitar Hero, Clone Hero, Fortnite Festival guitar controller stuff. Move that off to the side. So let's start off with just some straight up Guitar Hero stuff, and then we'll talk about the LEDs. So I'm going to switch this camera here back, and I'm going to grab my, let's go to the main view mostly, and I do a small bench cam in the corner. That should work. Okay, so the guitar's over there. So to back up a bit, this right here is a particular Guitar Hero controller. There are a few like it which have a wired USB connection. This one was made for Xbox 360, and I'm not going to unplug it right now, but the deal with it was it had an Xbox 360 control connector right here where you see this little connection. And it also came with a dongle that gave it a USB connector. So it goes from like a little 6-pin connector or something to USB, or 4-pin connector to USB. I believe you could plug it into Xbox 360 on the back over USB. Maybe you could plug it into a Windows machine of that era with some software. I don't actually know why they put that on there. But the disappointing thing about it is that it does not show up as a usable guitar controller on most operating systems, definitely not Mac or Linux, and I think even in a lot of games and applications on a Windows machine, it's not usable. So enter this right here, which is, I've got a Feather RP2040 USB host, so it is able to host on this end where the guitar is plugged in, and then it's able to translate the incoming messages and send them in the form you need to kind of almost anything. So I'm using this Santroller software, which we'll look at in a second, which allows you to remap things, configure things, say, okay, the thing I'm plugging it into here where this purple end is, could be a Switch, a PlayStation 4 or 5. It could be A modern Xbox could be your computer. I think it may even work with Android. I'm not sure about iOS. But this firmware on here that I have running, it's a neat all-in-one kind of package of my, pop open our little, this is our little snap case. Neat little package there of our Feather RP2040 USB host. So it has the host connector on there. There's nothing to solder to it. It's essentially plug and play, and then put your software or firmware onto there. Let me just check. I just got an alert. I want to make sure that we don't have any audio issues. No, we're good. So in this case, I've got it plugged into this Windows machine, and I'm running Clone Hero. And you can see here I'm able to, I disappeared myself. I'm able to pick songs on here. You can see I've got it, the display is running on this laptop, but I also have it plugged into a CRT through a HDMI scaler. So that's going to be laggy and terrible, so I actually won't play with it that way, but I just wanted to put it up on a bigger screen back there. And if I go ahead and pick a song here, turn up some volume. Hopefully this is not copy strikeable. So you can see it works. It also allows me to use the buttons here for navigation. There's a D-pad on here. There's a start and select button or start and back button. There's also an Xbox 360 button on there, which will bring up things like sort of game mode version of the Xbox Control Center on your PC, or I think you can have it bring up things like Steam or act like a Windows button or an Apple command button. Whammy bar works, accelerometer works. So all those messages that this is sending out to the thing that's hosting it, which normally would have been an Xbox 360, is what the Feather is able to grab and then do stuff to. So that's the sort of basic idea behind this. But I wanted to show you the software, and I'm going to go ahead and unplug this. The really cool next step, which is running LED lights, running NeoPixels off of it. So let me go over to the workbench, or rather my computer station here. And I'll get that out of the way. So what I'm going to do is I'll just set the guitar here. What I've got plugged in over here is just a second one of these feathers in a little case. And I'm going to plug the Guitar Hero controller into the Feather. But you can see coming out of this Feather on the back side, I have 3 wires so that we can run NeoPixels. And I just used a little JST connector so I could plug different strips into it. So here's a 30 NeoPixel strip that I have connected to a guitar strap. So I could play it like this. You may have seen me do this on Show and Tell the other week. So I'm going to plug in the guitar, and I'll hang this back here just so you can see the LED lights. Now, if I plug this in over there, I can play the game. Right now, it's just not going to do anything because I'm not running any game software on this Mac right here that I'm broadcasting from. But what you'll see is when I press different buttons, that blue one is actually looks pretty nice. I can bring this closer too. This is not the best camera for LEDs, but you can see here. So as I'm playing, if you're playing the game, this shows the exact pattern because the top button here is green, red, yellow, blue, and orange if you're playing on hard mode. I also have up and down strumming, strum down, strum up, and those work in combination, which I can't do right now, but you can see any combo of those will all light up. And then I also have a whammy bar. So if I'm holding down a note, I'm just using my elbow here to hold down orange. When I press the whammy bar, which is analog, you can see I can adjust the brightness of every 5th pixel. There is how I set it up. So as you're playing notes and holding a wow, 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 wow with your whammy bar, you get a little indicator there. So that's one possible way you could set it up, but that's not baked into it. It's actually a really nicely configurable bit of software. So I wanted to show you what that configuration looks like. So I'm going to switch over to this. Let me add a screen to this. One second. Oh, you can see it right there. I'm going to make it a little neater. So we'll go to maybe game, configure, Controller configurator. Okay. Okay, that should work pretty well. So now you can see this is the configuration software, which I can resize a little bit here for you. It has some vertical height to it once we get a lot of options on there. There we go. And right now, when you plug it in, if you have a microcontroller, one of the microcontrollers you can work with, which include this Feather RP2040, because it runs on most Pi Picos, RP2040s, it will start off in this sort of generic mode and say, hey, what board do you have plugged in there? Is it a replacement of the brain inside the machine? You're using GPIO and buttons. Or in our case, if we pick this Raspberry Pi Pico, I've already flashed this, but when it's brand new, it gives you an option of USB host using the Feather USB host. So it knows about this. Sanjay, who created Santroller, used that specific board here for this. So if I go into configure, you can see things like USB host input. So it knows right now I have this Xbox 360 guitar plugged into it, and I'm using GPIO pin 16 as the plus data pin, and then it'll use 17 automatically as the negative data pin for the sort of differential pair of data coming off of the USB device that you're hosting. Let me try to widen this a bit just so that you can see some of those options get cut off. So that, I just wanted to show you that USB host for a second. We can come back up to the top here under controller settings. You can see we can pick a whole slew of different things. I have a bunch of turntables. I haven't tried them with Santroller yet, but I love the turntable controllers, so it might be interesting to plug those in and play some modern, maybe open source versions of DJ software, or even use them in real applications. And then a whole bunch of other instruments and guitars, drums, keyboards, and so on. You can use MIDI keyboards as input. Noah was asking about using this actually to use the guitar controller as a MIDI controller. I don't think it has any provisions for that, but that could be a feature request potentially. So I'll go back to Guitar Hero controller, and then right here you can see we can, if we're using something like Mac or Raspberry Pi, we can tell this to just be an HID controller. On Windows, I'm going to say be an X input controller. So those are a couple options that we have there for what type of data it's going to send out after it's read the data coming in from the guitar. It can also be used for authorization. So there are some schemes where you need to convince a PlayStation that you're using a real PlayStation controller because of their sort of lockout DRM-y kinds of things. So there are some provisions for that in here as well. But you can see right there, Adafruit Feather RP2040 USB host enabled. That's how we are not wiring up a whole bunch of buttons and things on here, but instead just plugging USB into it. I'm going to make this a little bit smaller so you'll be able to see. You'll be able to see the lights back there. so I'll close this. There's some advanced settings about polling we don't need to worry about. There are presets, so you can save a preset and then re-import it if you get everything tuned the way you like, and maybe you're setting up a couple controllers so you can play with a friend. You can import and export a little controller file, which is nice. LED settings. So what I've done here is I've picked one of the data pins, GPIO pins. It's GP14, which I believe is A0 on the Feather. So that GP14 pin is my data pin for WS2812 or NeoPixel RGB that is in GRB color order. But you can see you've got a lot of options. You've got APA 102s, which are the dot stars, and then some other variants and a whole bunch of different color orders. You can also do RGBW if you want to do some really nice white lighting effects. LED count. So I've told it I have a 30 NeoPixel strip here. You can also tell it if you have persistent effects after a second of, or however many seconds of inactivity, it will turn them off. I'll set that back to 0. Now you can see when I make a change, it wants me to hit Save Settings, which will recompile the firmware and reflash it. In fact, I'll do that right now. Just so you can see at the bottom there, it says looking for device. It found it. It's writing or building compiling the firmware, writing it to the firmware. And all in all, it takes like 20 or 30 seconds, and it's done. So I don't think we'll see any changes from that there, but just press some buttons and see that it's still working. And now what we can do is take a look at these LED options, which they're not as open-ended as just running something like WLED or fancy LED or fast LED inside of Arduino or CircuitPython, but we do have a lot of options for mapping things that we do in the controller to LEDs. There are also options in some games to listen to in-game events and run LED effects based on those. I haven't touched those yet, so I don't know anything about how they work, but I believe for some games you can have, when you go into like star power mode, you can have your LEDs light up just based on a game event, not always based on controller stuff. So here you can see I have for each button, if I go ahead and press, let's say, the back button or the start button, you can see those are lighting up in the interface just as a controller tester, so I can see that the controllers are being read. And I also, since I added this 30 NeoPixel strip, have 30 little NeoPixel options here to do something with. So let's go ahead and I'm going to steal the first NeoPixel away from my whammy bar. So I'm going to go ahead and deselect that. And then let's go up and map that to one of these buttons that I was using. How about the back button? So I can go to the back button, select an LED, pick a color for it. Let's just make it bright green. And let's save settings. So again, we're going to write recompile and then flash that to the board. And now you should see that top LED right there is lighting up when I press the start button on the controller that's plugged into it. So you can see that right there. Right, and that's exactly how all these others are set up, is just go in and pick them. For a group of these, I set them up as 4, so we get like a nice big chunk. So that's how green button right there lights up 2, 3, 4, and 5 is green. Red button does 7, 8, 9, and 10. And remember, I have the whammy bar for the intermediate ones there. So that's all whammy bar stuff. And you could do tilt. So if you look at there's an accelerometer built into the guitar, So you can do calibration. Let's say you usually hold the guitar like this. You can say, okay, I'm going to calibrate that, hold it level, tilt it up, and it's done. So now that's the sort of default state of it. If you're doing games where lifting it up like that gives you a power up. And same with the whammy bar, that has a little calibration that you can do. You can see the analog values there from 0 to 65, 20, 280. You can change the minimum and maximum if you don't want to accidentally, if you want to have to press it harder, or if you only want to have to press it in a little bit and go all the way to the top, you can adjust those minimum and maximums. You can also have a dead zone set there. This one does not have a slider. I actually can disable this. Some of the guitars have a capacitive touch strip that lets you do certain effects. I can't remember what those are. I don't know if I ever had a game that had that kind of controller, but I've disabled that now, so I don't have to worry about it polling that or doing anything with that. So all of those things now will translate to that, and you can see here I just have a temporary gaffer tape solution of hooking that up to my guitar strap. But if I go ahead and pretend I'm wearing that as a guitar strap, turn this way and get back into camera view. You can see as I'm playing, it's kind of upside down, but as I'm playing, my guitar strap will light up, which could be kind of cool for streamers, for people who want to put on a bit of a show, who actually know how to play the games well. You can sort of see if someone's on camera what buttons they're pressing just based on this stuff lighting up. So David S. says, can you play something by the Beach Boys? So I'll go ahead and write this up as a addendum to the guide. I already put together a simple one-page guide on getting set up with the feather and putting Sandtroller on there and getting it going. The second page will just be on how to do some LED effects, and that could be any strips that you want. Let me hide this for a second, and I'll show you. If I unplug my little LED strip there, I use this JST connector here so that I can plug in a different set of strips pretty easily. Here's some of these neat star-shaped LEDs that we have in the store. So I've gone ahead and put a JST connector on the end of that temporarily. If I plug that into the controller, I think this one's only 20, so I don't think we're going to get all the colors there, but so you can see I can light those up, and this is actually a different, that's supposed to be green, so this is actually a different color order strip here. So we could go into, I won't do it now, but we could go into the software and say, oh, these are not GRB, these are BGR, or whatever the change is that's necessary right here in, collapse all that. Up here in LED settings, instead of GRB, I think this would be BRG maybe for those strands there. All right, so that is all the latest on that. One other thing I wanted to show actually in here is that there are settings that I don't have configured at all. If we go to add setting, you can pick things like, oh, I want Wii inputs, and then you can use the little Wii Chuck connector and a Wii guitar. So that wouldn't be a USB host, that would be a little I2C Wii connector. PST controller or PS2 controller inputs. If you're doing Fortnite Festival, you can add those modes. So those are very particular commands that it's going to send out to your PC that you're playing Fortnite Festival on. Here's all of these individual buttons. This is more useful if, rather than USB hosting it, you are building your own guitar, maybe wanted to add a second green button somewhere else on it that you can hit along with the strum bar, where if you're really customizing, you can go ahead and add in just the individual modules that you need here and configure what they're pointed at. I'll go ahead and remove that one. And then you can start doing things like saying, okay, which GPIO pin is this arcade button or this key, mechanical key switch or something connected to. You may, if you're a long-time viewer, you may remember I've messed with these guitars before. There was one episode early on where I took apart one and found that, in fact, there were a couple of mechanical key switches, I think cherry mechanical key switches in the strum bar of one of the Guitar Hero controllers I'd pulled apart. Okay, I think that is it. So thank you so much for coming by. Before I go, I will remind you, if you want to go ahead and shred your guitar and you want to save some money doing it, maybe you want to buy one of these Feather ESP32s that we looked at earlier, or you want to buy one of these Feather USB host RP2040s and do some guitar stuff, but you don't want to pay full price, you want to save 10%, then that is your coupon code, shredded, and that is good until midnight tonight. Get 10% off with that. Phew, all right. Hey, thanks everyone again for stopping by. Thank you to the Discord. Let me know if anyone has any other thoughts or questions before we go. Otherwise, we will wrap it up right there. We have, I believe, a deep dive. Maybe Scott's last one. I think Scott's getting ready to go on leave. I can't remember. He was talking about that yesterday. So either Scott or Foamy Guy should be having a deep dive tomorrow. Lady Ada doing Desk of Lady Ada types of things over the weekend, and then we'll be back on Tuesday with another product pick of the week. Wednesday with 3D Hangouts, Show and Tell. I will be guest hosting it, I believe, next week. Yeah. So if you want to come on Show and Tell, I'll be there for you. And then Ask an Engineer that night, and more and more and more. So some nice, rock on. Thank you, Andy Calloway. Appreciate you. Thanks, everyone. Again, for Adafruit Industries, I'm John Park, and this has been John Park's Workshop. Bye-bye.